Hello, this is Tristan Todd with Tintri Tech Marketing. We hope you enjoy this playback of the May 2017 demo series on 4 defining pillars of enterprise cloud. And I'd like to thank my teammates Bill and Tomer for assisting me in preparing and delivering this demo series. Let's get started. I think everyone has probably gotten tired of slides like these. Over the last year, I think every cloud partner, every large enterprise has been examining or studying their journey on the move towards a cloud model for operating a data center or operating infrastructure. And I think we can all agree that most everyone has virtualized most of their x86 infrastructure. Most of our customers have actually gone well beyond the 80% mark. And I think most of our customers are north of 95% virtualized with very little bare metal infrastructure in the data center or in their hosted cloud. I think everyone is moving towards an enterprise model where you have a blend of cloud services on premises and publicly hosted cloud solutions. And that might be a mix of applications as a service, mixed with software as a service, mixed with a traditional kind of on-premise cloud experience. So in looking at the NIST definition of enterprise cloud, these are kind of the textbook definitions of what that enterprise cloud represents. It's the typical cloud constructs of resource pooling, heavy automation, flexible scale, measured services, and then a self-service component. And as you move to the enterprise cloud, of course, you're blending traditional applications and then cloud native architecture in the app layer and consuming these services really with the same level of comfort, the same level of automation, regardless of whether it's on premises or out in the public cloud, whether that's AWS or Rackspace or Azure or what have you. Essentially, there's 4 major building blocks or pillars to enterprise cloud. And we break these down into 2 categories: the level of abstraction through autonomous operations and machine level analytics, and then open API-based automation and self-services. What I'd like to do now is take each of these 4 pillars and dive a little bit deeper, and then show you some compelling demos that explain the relationship with an enterprise cloud model. Let's first take a look at autonomous operations, the first pillar of enterprise cloud. Autonomous operation is eliminating all the manual intervention that might be required to operate a big environment at scale. So depicted here on the slide, the illustration shows how we break all the virtualized workloads up into swim lanes, and regardless of block size, regardless of I/O intensity, separate workloads can cohabitate and deliver predictable performance in isolation, resulting in very predictable performance. Essentially, the Tintri operating system is operating autonomously and making sure that performance is very predictable by eliminating any of the noisy neighbor virtual machines from overwhelming the system with storage workload. I'm now in the Tintri Global Center interface in my lab environment, and here I can see all of my VM stores, my virtual machines, my service groups, and all of my pooled resources. So this is a great central point of administration for looking at all of my containerized virtual machine workloads. I've got about 7 or 8 VM stores, looks like 8 right now under management. I can go out and interact with Tintri Global Center as my single point of administration. And the nice thing is there is quite a bit of autonomous operation happening with Global Center. So what I've done is I've pooled my VM stores so that my VM stores operate as a team, at least 5 of them do. And I actually have continuous recommendations coming in from Global Center. So from an autonomous fashion, last night while I was sleeping, Global Center was actually evaluating my environment and making some recommendations based on some of the load. And right now, the current active recommendation is that one VM should be moved off of my 5080 all-flash system. And what it's going to do is provide some benefits. So we call these outcomes, but basically the derived benefit from this move is illustrated clearly. And I get to see my space utilization and performance impact. And what I can do is I can go ahead and hit the big red execute button to make that move happen. I can also flag this as a not useful recommendation, and through fairly powerful learning mechanisms, then Global Center will start to get smarter over time and make better and better recommendations. And I can certainly go out and make migration rules, so I can enforce affinity and anti-affinity rules, and I can make decisions based on my different storage platforms within my environment. So this is yet another thing that Tintri does very well, is offering those autonomous services on the back end, so that your environment is smarter and you can focus on things that matter rather than balancing load across your different systems. So probably my favorite pillar when it comes to enterprise cloud and how we fit is analytics. And analytics really are kind of broken into two different flavors. There's real-time, and then there's predictive or forecasted analytics. And the idea is that through data, you can make better decisions in real time, or you can research hypothetical scenarios based on data and really make good decisions. So what I'm doing is I'm looking at real-time statistics on one of my VM stores using the Tintri APIs and an open source platform called Grafana. And I'm studying the metrics in real time, and this allows me to kind of make a quick decision visually based on my load, if my environment is healthy, where my hotspots are, and the like. So right now I've color coded my dashboard based on the latency value. Green is good. So I classify anything under 5 milliseconds of latency as nice and green. Anything above that, I start to change this field based on the latency value. I change to yellow and then orange and red. I can see that VM level round trip latency average listed here. So I can see that on my all flash system that I'm looking at, I'm enjoying less than a millisecond of latency. And that storage latency value is fairly low. And I can see, my network, my storage, my host latency, all of that is pretty nominal. So I'm enjoying very good performance here. And then I can look at my real-time IOPS load. So from a real-time perspective, through the proper API calls, which are documented out there on GitHub and SourceForge, you can kind of use your own ops management tool, whether that's vRealize Operations Manager or an open source platform like Elk or Grafana or Kibana or Nagios or any one of those solutions. You can use our APIs to kind of build your own visual analytics dashboard. All Tintri systems under management, meaning they are hooked up to the phone home system, actually report capacity and performance utilization as well. And what we do is we host a SaaS offering called Tintri Analytics. It's hosted in the cloud. So your system may sit in your data center. We actually take performance information, we take digest information from your system periodically, and we put everything up in an analytics platform. This is a pretty exciting platform because we are an agile development environment, and we do make updates to this software as a service offering every couple of weeks. So we have a new release, we introduce new features based on partner feedback, based on customer feedback, and we give you visibility into your current state of affairs. In this case, I'm looking at a machine count based on today's date. I know what capacity I'm using. I know the performance consumption. I know what amount of my data is actually transacting I/O. And based on the way I've carved up my environment, in this case, I've got a bunch of SQL systems, test apps, Veeam systems. I can see who's using the most space, who's using the most performance, and then who's transacting the most I/O. Working set is one of the things that Tintri does that very few storage vendors do, and that is that we provide you insight into how much of your data is actually active, how much is actually transacting. So it gives you a better idea of how much of your capacity is actually active capacity versus just kind of traditional storage. So in addition to this kind of quick overview, we also map out trends. So we can take a look at a subset of our environment. We can study different date and time periods. In this case, I can look at a SQL environment and I can look at a point in time. I can look at space, I can look at performance and working set and see how things are trending over time. The other thing I can do here is I can look at trend lines based on a specific period of time or going back a certain amount of time in history, and then I can forecast where I'm going to be out there in the future. So this by itself is a pretty attractive capability because I can choose a subset of my environment. In this case, I've got a single array listed, and I can see, over the next couple of months leading out to August 2017, how am I doing as far as capacity? And if I extend that forecast line out, I can see that it looks like my summer and into next summer on this particular system with this particular type of workload is going to be just fine. If I look at a different system in a different period of time, in this case I'm looking at an all-flash system, I see that it looks like things are going to get kind of interesting around March 2018 based on my present rate of consumption from a space perspective. Performance and working set, I'm just fine. But I do have a capacity issue brewing, and I may want to consider a what-if scenario. A what-if scenario could be me introducing an additional storage system. So I have the ability to actually add systems. So I can choose a scenario. I'll close this existing scenario and come up with a new one. So I can create a new action plan and basically say, based on a budget request, I'm going to budget for a new Tintri VM store. I'm going to do that according to my budget calendar, where I'm going to get funding in September. And once September rolls around, I'm going to budget for an all-flash system fully loaded, and I can model what that will look like. You can see that I don't have a massive impact on the amount of capacity or performance my environment. If I deselect all of my VM stores and just study my existing flash system where my SQL workloads live, you can see that I'm going to have lots of capacity headroom in September timeframe. I'm going to gain a lot of capacity, and it's going to reduce a lot of the capacity pressure. I'm going to stay well below that 80% load line, which makes me happy. It'll make me sleep at night, and I don't have to worry about the space impact of standing up new systems as part of my job. So automation is kind of the key to efficient operation of your cloud, whether it's private or public or blended. And the idea is that automation should be as efficient as possible on the back end, such that you're not executing very tedious workflows like this workflow that I have depicted. This is kind of a logical workflow that represents a kind of a common storage operating environment. And what Tintri aims to do with our automation that exists on the back end is really make things a lot more efficient. We take care of a lot of the heavy lifting, a lot of the complex orchestration behind the scenes, and what we present to you as consumable automation is very slick, very elegant, and very efficient. I first want to give you an example of automation that just makes no sense. I'm going to log into a legacy enterprise cloud configuration and consume some services. Here I'm logging into vRealize Automation and a self-service portal. It's backed by vRealize Orchestrator on the back end. So let's go ahead and take a look at the service catalog. I'm logging in as a non-administrative user, someone who would consume cloud services. And you can see I'm met with a sea of options here, and none of them are really relevant to my job. A lot of these are LUN and disk aggregate-based policies and services, and they really don't make sense for me as a server owner or someone who wants to spin up services. So let's take a look at a better way to do this. In support of our mission to help the world build better enterprise cloud services, Tintri has released a vRealize Orchestrator plugin, among other things. And this plugin makes it very easy to integrate a very popular orchestration framework in vRealize Orchestrator into your environment. So automation is a click and drag type of proposition. And let me show you really quickly what's going on under the hood, and I'll show you what it looks like from a self-service portal platform. So here I am in the vRealize Orchestrator client, and I first want to show kind of a legacy storage platform and the complexity that it presents from the automation capabilities. Lots of different options here, but not many of these capabilities are relevant to a cloud consumer in a enterprise cloud. So if we take a look at the Tintri plugin, it is a very, very stripped down and focused automation toolkit. It is really fixated on the most essential tasks that are machine level tasks that you might present out to one of your cloud consumers. Things like cloning VMs, snapshotting replication services, quality of services, snapshot, updating replication state, and the like. And Tintri also provides a number of actions that consumers that our customers can utilize to build very complex automation workflows. So lots of underlying tasks are captured in these modules called actions, and these are bits of code or snippets of code that you can use to drag and drop your way to very complex but very meaningful workflows. So I'll take you through some custom workflows that I have in my environment. Here's a workflow that I have built. And what I've done here is I've linked a number of off-the-shelf Tintri workflows and actions to build a meaningful service that my users will benefit from. So let's go ahead and take a look at this orchestration workflow in action in vRealize Automation. I'm now going to log into my Tintri integrated cloud as a username lgaga. When I log into this environment, I'm met with a number of service options in the catalog. So I have a number of services here. I've got some day zero services. For instance, that workflow I just highlighted in Orchestrator, I can consume here in vRealize Automation. So I'm going to go ahead and request one of those Apache web servers. I need a couple of them, and I'm going to call these Web Server West. I'm going to select two of them. They each need a couple of CPUs and a couple of gigs of RAM. And I want to choose my gold service level. Gold service level affords me the snapshot and replication services that are in line with my corporation's gold level BCDR capability. And finally, I'm going to set service level agreement based policy for performance. This is going to be a development environment, so I choose dev from the list and click submit. And what I've done there is I have basically requested services from the service catalog, and in the background now, my web servers are being deployed and their services are being configured based on my corporate policy. Now, in my environment, if I already have some servers deployed, in this case, I've got a handful of systems deployed. What I can do is I can take an off-the-shelf resource action. So I'm going to take my Tyres 019 server and go ahead and set up some SLA-based services. So again, I'm kicking off a vRealize Orchestrator workflow from the vRealize Automation interface. So here I select whether or not I need snapshots. In this case, I do. And I have my snapshot policy here listed. I'm going to choose the gold level policy. It says, do I need replication? Yes, I do. I'm going to choose yes. And I have a choice of replication targets. I'm going to choose Lilea, Sweden. And finally, do I need storage QoS? The answer is yes, I do need storage QoS. I've got a description here of the QoS policies. In this case, I'm going to choose the development policy for the system. Click submit. And now my enterprise cloud services have been requested. And in just a few seconds, they have been processed. So returning to the vRealize Orchestrator interface, here you can see that I've got a very basic logical set of tasks I need executed. They're all very VM specific, and I can deliver them in a nice consumable service catalog. So here I am reaping the rewards of Tintri API-based automation. I want to quickly highlight a non-graphical automation resource, the Tintri Automation Toolkit, which is a collection of documented PowerShell commandlets and example commandlets that you can access from support.tintri.com. And this is a great way to get started with some PowerShell-based automation in your environment. You can also go out to GitHub and search for the Tintri PowerShell examples page. Just go out to GitHub and search for Tintri, and you'll see that the PowerShell examples page is chock-a-block with a bunch of vSphere and Hyper-V based commandlets and scripts that give you some ideas of how you can automate things in your environment. So let's first start with a very simple bit of automation. I'm going to run a PowerShell commandlet that I built called You Want Clones. And what I'm doing here is I'm executing this PowerShell script. I'm going against my Tintri Global Center instance. I am going to present my credentials, and I'm being presented with a challenge. I am going to put in my Global Center credentials. It's going to ask me for which virtual machine I'd like to clone. I'm going to clone my server, which I call Chicken. It's my favorite server, and I'm going to call my clone Eggs. and I need 2 of these clones. My script here I've customized to provide a minimum of 2 and a maximum of 15, but I could change these variables as I see fit in the script. Go ahead and request the information for the resident data store. So this is where the chicken VM was found as far as a Tintri data store. So I'm now going to put in the Tintri data store credentials. And very quickly, my clone tasks are being executed in the back end. And what's great about this task is I'm issuing a bunch of Tintri API calls, and the virtual machines are being created, they're being customized, they're being brought online, and they're being entered in the vCenter database. So these are completely viable clones, and all of the automation, all of the complexity as far as putting these systems online, making sure they're in the right folder structure, in the right efficient configuration, is all done by automation on the back end. So we'll let that run for just a second, but that is kind of basic automation. I got a message here that my egg VMs were built. Got a little whoop whoop message there, which means my automation on the back end is running, and I'm consuming this via PowerShell in this example. The key to all of Tintri's automation capabilities, and really many of our consumption models for our features, is our REST API. It's a very well documented open API that you can use to consume services. So while we want you to use our award-winning user interfaces, you can use your interface of your choice. If you go out to SourceForge or GitHub and you search for Tintri, you'll see that we have a ton of examples of Tintri automation. I'm just highlighting the Tintri Python software development kit. It's out there with tons of documentation, tons of examples of how you can use Python to introduce automation to your environment. So if you're not a PowerShell fan, certainly you can do everything in Python if you'd like. I'll now cover the final pillar of enterprise cloud, and that is self-service. You can't operate a cloud of any type without a self-service capability, and that is empowering your users with a ability to consume services in a very flexible, efficient manner, and kind of doing away with the old archaic request processes that have bogged down the traditional enterprise. Let's take a look at a few examples. So here I am in OpenStack. I've got an overview of my entitled services and a view of my quotas. I can see that I've got no limits on instances. I've got some storage capacity. But if I'm an application owner and I want to stand up a new system, I can simply come into the instance view. I can select launch instance. And in this case, I'm going to go ahead and select an existing image. And my available images are out there are actually living on the Tintri storage platform. I can select an image. I can customize the t-shirt size. So I can come in here and I can set whether I need a small, medium, or large. I can choose my network. And once I execute this command, I'm actually passing API calls out to the Tintri sender driver. Oop, I better give it a name. We'll just call it Tomer. Click launch. And in short order, I'll have a compliant image or a compliant system built in the form of an OpenStack instance based on a standard source image. And this is a Tintri efficient clone operation that was executed via all of the automation and all of the API calls behind the scenes. But it is a very easy and fast way to create a self-service model. Some customers are not doing OpenStack. They're looking at different types of cloud management platforms. And oh, by the way, that took about 8 seconds to render. And I've got a completely viable CentOS box out there named Tomer. So Tomer, enjoy your new server. So here I am. Yeah, no worries. So here I am in CloudBolt. I've got a fictitious company here called Fogtree Capital Management. I've got a number of systems out there deployed. And if I'm a server owner, I might want to engage in a little bit of self-service functions with my servers. So I'm going to go out and look at one of my systems. Executing a quick search here. There we go. So here I've got my HQTM lat01 server, and it's got some information here presented in the CloudBolt interface. And all of this information is being fed from the vSphere API. But what if I want to see some Tintri goodness? So via self-service and via those API calls, I'm actually rendering some Tintri level stats that are kind of meaningful. I noticed that my latency values are a little bit higher than normal. If I zoom in on this this table, I see that it's kind of a periodic consumption of I/O, and that latency is kind of continuously high. I'm pushing just under, looks like 3,000 IOPS. Now, if I interact with this graph and uncover where the latency is coming from, I can very quickly troubleshoot where the latency, where I'm finding that latency. So if I select storage, I see that I've got no latency on the storage. If I uncover network, I see very little network latency. But if I uncover host latency, I see most of my latency is coming from the host. And this means that I've got an overloaded host. The storage and network resources are performing just fine. I really need to start to study the host and find out why that, in this case, vSphere host, is overloaded and why it's giving me latency in the form of queuing. From a self-service perspective, I can also do things like request Tintri snapshots. This is a space-efficient, crash-consistent snapshot. And I'm just going to call this howdy, if I can type. Sorry about that. And I click run. I'm submitting a snapshot request to the CloudBolt scheduler. And this is just an API call that runs against the VM store where my VM resides. It took 2 seconds. I now have a record of this snapshot in the server log within CloudBolt, within my cloud manager. And I didn't have to interact with a Tintri UI. I didn't have to submit an API call myself. What I'm doing is just enjoying the integration that this cloud manager has with the Tintri storage layer underneath. So from a self-service perspective, this is a great way for me to execute this API code, this Python code, using the Python SDK, but consumed via a very clean, elegant self-service portal. So whether you give people access to PowerShell or OpenStack Horizon dashboards or a traditional cloud manager that can manage lots of different types of clouds, this is how a self-service integration works with Tintri. With that, we've covered the 4 pillars of enterprise cloud, the abstracted autonomous operations and analytics capabilities that Tintri affords, as well as the API-based automation and self-service. And I would like to remind people that the core features that make Tintri a fantastic storage platform, and that is performance, reliability, simplicity of operation and implementation, plus all of those great things you can do with snapshots, clones, sync VM, replication, with our VM and vDisk level of operation, meaning we operate at those VM and vDisk atomic units of measure, fronted by a very elegant standards-based REST API, makes us a very, very good layer in an enterprise cloud platform. That wraps up the demo series for May 2017. Thank you so much for watching. Please click subscribe to the Tintri Tech YouTube channel. Also check us out on the Tintricity Customer Hub, and you can always reach me on Twitter at Tristan Todd. Thanks so much. Have a great day.